Hello, I welcome you all to this another interesting screencast, and the problem reads replace the loading by an equivalent force and couple moment acting at point O. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Alright, so we've been asked here to replace the loading by an equivalent force and couple moment acting at point O. So first things first, we are going to get the equivalent forces of each of these distributed load. We have distributed load from O to A is rectangular, from A to B it is triangular. All right, and this point here is also a 200 newtons per meter. Great. So we have now two portions of loads. I'm going to get the equivalent forces for each one of them and then later on sum them up algebraically about point O. Alright, so like I said, we have one block of distributed force which is rectangular, and then we have another block which is triangular. Okay, great. So with this in mind, let's get the equivalent of each one. We are going to have an equivalent midspan for the rectangular, and we'll have another one somewhere there for triangular. Okay, these are their centroid positions. Okay, great. Let's indicate their location with respect to O. Okay, so something like so, something like so, something like so. Great. So this one there, it is just half of 4. Okay, so this is just going to be half of 4, okay, which is just equal to 2 meters. All right, let me use some the one that is a little bit thicker. So this length here is just half of 4, which is just equal to 2 meters, and so is this one 2 meters. Then this one here, it is 1/3 of 3, okay, which is just equal to 1 meter. Right, then this triangular load is going to be equal to, that's the area under the load diagram. So this is equal to half, okay, times the height. So this is half times the height, which is just 200 newtons meter, times the length, which is equal to 3. Okay, so 200 by 3 is 600, then half of that is 300. Right? Yes. Then this one is just equal to, also its area under the load diagram, which is just equal to, the height is 200, times the length. What's the length? Is 4, and therefore this is just going to be equal to 800 newtons, and this one is 300 newtons. Great. So when we have all this information, we can find the resultant force. So say the resultant force, summation of forces in the y going up in our reference, this is going to be equal to the resultant force in the y direction, which is equal to minus 800 and minus 300, which is equal to minus 1100 newtons. Great. And then we'll need to find the summation of moments about point O. Okay. Summation of moments about point O. Okay, is just going to be equal to anti-clockwise being our reference. So we have a negative moment 800 by the lever arm, which is 2. All right. And then we have another negative moment, which is 300 by the lever arm. The lever arm is 1 plus 2 is 3 plus 2 is 5. Okay. And then this summation of moments, or just a moment about point O, is going to be equal to, let me just write it down here. So this moment is just going to be equal to 800 by 2 and 300 by 5. So we are going to have a minus 3100 Newton meters. Or you can also write this as equal to 3100 Newton meters, and this one is clockwise. Alright, you can just draw this and replace our resultant force and the moment. So we are going to have the resultant force there like so. Okay, and this value is equal to FRY, which is just equal to 1100 newtons. And then we have the moment. This is clockwise, so we have this moment, and this moment is equal to MO equal to 3100 Newton meters. Alright, so I'll not indicate the support, I'll just leave it like this. I just wanted to show the resultant force and the couple moment at point O. So this is about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.